Okay, so let me read this to you guys out loud. It says, this is problem number 37. It says, it takes 10 identical pieces to form a circular track for a pair of toy cars, for racing cars. If the inside arc of the track is 3.4 inches shorter than the outside arc, what is the width of the track? So this is like racetrack, right? So let's draw the picture and then we'll start labeling things. So I have a piece of racetrack that looks like this. Now I don't know how long one is over the other. The only thing I know is that the arc length is 3.4 inches shorter on the inside than the outside. So this is like a racetrack thing, right? And so if this is X, oops, let me change the color back. We'll change it to this. If this is X, then this is X minus 3.4. So those are the two lengths. And so remember that our arc length is based on the radius times theta, which is measured in degrees. Now, it said to make a complete circle, you needed 10 pieces of track. Now, the reason they gave us that information is technically, we kind of need to know what theta is. Well, theta is 1/10 of a circle. Does that make sense? So if a circle is 2 pi, then theta for this, or in other words, if a full circle is 2 pi radians, right? Then we only need 1/10 of that. So our radius, which we'll talk about later, but our measured theta would be 2 pi divided by 10 for both arc lengths, okay? And so that's the first start. Now if you reduce that, it's really pi over 5, right? So theta is pi over 5. Basically, we need to figure out what this length is. We need to solve for x. So I have two equations. Okay? I have, let's do S out is equal to the radius times theta. Alright? And then I have the arc length of the inside track, which is equal to the same radius and the same theta. Does that make sense? And so what I'm going to have to do then is I'm going to have to rewrite this. Well, what is the length of the outside arc length? So we've got two equations. We've got x is equal to r times theta, and then we have x minus 3.14 is equal to r times theta. Now the only thing that's different is the radius length. So the radius here is out and this is in. So you can see here that the radius on the inside is shorter than the radius on the outside. Okay? So this is in, and, or no, this is outside. Out. And this is in. Does that make sense? Now, if I take both equations and I set them equal to x, because x is the same for both of them, I really have two equations. I have x is equal to the radius on the outside times theta, and then I have x can also be equal to the radius on the inside times theta plus 3.4. Does that make sense? Now, since x equals x, what can I do now? Set them equal to each other. So what I have is I have the radius on the outside times theta, is equal to the radius on the inside plus, times theta plus 3.14. Does that make sense? Now what they're asking is what is the width? And what is the width? This right here, the width, is the radius on the outside minus the radius on the inside, isn't it? So couldn't I say minus the radius on the inside, right, from both sides, times theta? And so what I end up with is I end up with the radius on the outside times theta minus the radius on the inside times theta is equal to 3.14. So now we said that what we're looking for, the width of the track, is equal to the radius of the outside minus the radius of the inside. So I got to get those thetas out. So if I factor out theta, I get the radius on the outside minus the radius on the inside is equal to 3.14. Or my width is equal to 3.14 divided by theta. But we know what theta is. It's pi over 5. Now remember that when you divide by a fraction, you multiply by a reciprocal, so the width is really 3.14 times 5 over pi. Or, let's do that on the calculator. 3.4, was it 1.4 or 3.4? I keep saying 3.14 because pi is on my mind. But it was 3.4, right? Okay. So I have 3.4 times 5 divided by pi. So I got 5.4, let's make sure that's the right answer. Yeah, 5.4 inches. So it's approximately 5.4 inches, because that was the unit that we started with. Any questions?